Okay, Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, everyone. Today we will study about production of rotating magnetic field, which is the important part of the AC machines or induction machines. So this phenomena is very important for the concept of AC machine, which may be a single phase or a three phase. On this phenomena, these machines are working. So let's see how this rotating magnetic field is produced and how it is rotating within the stator of the machine. So uh, production of rotating magnetic field with a two-phase supply. So bear in mind the rotating magnetic field is only produced by a three-phase supply and two-phase supply, and there is no production of rotating magnetic field by a single phase supply. But we have plenty of single phase machines. So the question arises over here that how they are working when there is no production of rotating magnetic field by a single phase. So the technique we are using to split the single phase supply within the two phase, they are just look like in two phase. We are just split the single phase supply within a two. So this single phase supply by splitting a within by two, so it's look like in two phase for the machine, and hence there is a minimum requirement for production of rotating magnetic field. So that's why a rotating magnetic field is achieved by a single phase. The, the phase splitting may be with the help of a capacitor or maybe with the help of an inductor. So that is another techniques, to produce a rotating magnetic field with the help of a single phase supply. So now let's see, with a two phase supply production of rotating magnetic field, the principle of a two phase two pole stator having two identical windings 90 space degree apart. अच्छा, टू फेज है, टू पोल है, टू आइडेंटिकल वाइंडिंग है, 90 डिग्री जो है ना स्पेस अपार्ट. सो 90 डिग्री पे जो है ना एक दूसरे के पड़े हुए हैं. नाउ द फ्लक्स due to the current flowing in each phase winding is assumed sinusoidal. The assumed positive directions of fluxes is over here. Now it's in two-phase supply over here. This is neutral, by the way, common or neutral. This is first phase and another one is two phase. So two windings of stator is drawn over here. Each one is 90 degree with another one. Now let's see how the production of rotating magnetic field is. So now this is the sinusoidal wave diagram for the two-phase supply over here. 120 degrees phase difference between these two sinusoidal waves. Okay, so phase 1 and phase 2 are here. This is flux phi. And by the way, this flux is also a sinusoidal wave over here. Just follow this wave. Up, apart from the hysteresis loss or a hysteresis loop, it will be look like this. The flux will be l- produced by a sinusoidal wave will follow this sinusoidal waveform. This is phase 1, phase 2, and hence phi 1 and phi 2 are the magnetic field produced by these waveforms. So let phi 1 and phi 2 be the instantaneous values of the fluxes set by the two windings. The resultant flux pi r at any time is the vector sum of these two fluxes phi 1 and phi 2 at that time. So phi r is the resultant flux at any time is the vector sum of these two fluxes at that time. We will consider conditions at interval of 1 of 8 of the time period, that is interval corresponding to angle of 0, 45, 90, and then 135, and then 180. So these are the intervals we will observe the resultant flux and the direction of the flux, by the way. So it will be shown that resultant flux phi r is constant in magnitude. Yes, magnitude इसका constant होगा. That is equal to phi max or phi m, the maximum flux due to either phase and is making one revolution per cycle. And in other words, it means that the resultant flux rotates synchronously. So it is making one revolution per cycle. In other words, it means that the resultant flux rotates synchronously. So resultant flux are rotates synchronously. Now this is again phi 1 and phi 2, phase 1 and phase 2 waveforms, and then this is the phi max over here, by the way, and phi 1 and phi 2 are the two phase fluxes. Now let's see when theta is 0 degree, that is corresponding to point 0, where phi 1 is equal to 0, but phi 2 is maximum. So look at over here, this is the 0 point over here. Phi 1 is 0, but look at over here, phi 2 is a maximum value over here. By the way, it is negative side, but it is maximum, equal to phi max and negative. So corresponding to point 0, phi 1 is 0, but phi 2 is maximum. That is equal to phi max and negative. Hence, resultant flux phi r is phi max, and being negative is shown by the vector point downward. So this is resultant flux is equal to phi max, theta is equal to 0, it is downward. Now, when theta is 45, that is corresponding to point 1, that may be this point. So at this instant, phi 1 is phi max by under root 2 and is positive. Phi 2 is equal to phi max divided by under root 2, but it is still negative. The resultant is phi r is equal to under root phi max by under root 2 square plus phi max divided by under root 2 whole square. So that is equal to phi max. Although this resultant has shifted 45-degree clockwise. So now look at our here. Phi 1 is over here, that is phi max by under root 2, and phi 2 is equal to phi max divided by divided by under root 2, and their resultant flux phi r is equal to phi max, which is rotated by a 45-degree clockwise. So now it will be look like this. Now the theta, when the theta is 90-degree, it is corresponding to point 2. Here, flux 2 is 0, but phi 1 is equal to phi max and is positive. Hence, phi r, which is a resultant flux, is equal to phi max and has further shifted by an angle of 45 degree from its positive in B, or by a 90-degree from its original position in A. So that is resultant flux phi r is equal to phi max, and it is further shifted by a 45-degree from the previous point. So the total shift is 90-degree from initial one, that is a 0 point. Clockwise, it is shifted by a 90-degree from its original position. So when theta is equal to 135-degree, that is corresponding to point 3. Here, phi 1 is equal to phi max by under root 2 and is positive. Phi 2 is equal to phi m by under root 2 and is also positive. The resultant phi r is equal to phi max and has further shifted clockwise by another 45 degree. So look at over here, it is phi 2 is equal to phi max by under root 2. Phi 1 is equal to phi max divided by under root 2. So the resultant is phi r is equal to phi max, and it is further shifted to 45-degree from the previous point and 135-degree from initial one. Clockwise. So now theta is equal to 135 degree over here. When theta is equal to 180, that is corresponding to zero point 0.4, and here phi 1 is equal to 0, phi 2 is equal to phi max, and is positive. Hence, a resultant flux is equal to phi m and has shifted clockwise by another 45 degree or has rotated through an angle of 180 degree from its position at the beginning. So this is the resultant flux that is equal to phi max, and it is the theta is 180 degree from initial one. And now hence we conclude that the magnitude of the resultant flux is constant and is equal to phi max, the maximum flux due to either phase. Number two, that the resultant flux rotates at synchronous speed given by ns is equal to 120 fp revolution per minute, where f is the frequency and p is number of pole. However, it should be clearly understood that is that in this revolving field there is no actual revolution of the flux. The flux due to each phase changes periodically according to the changes in the phase current, but the magnetic flux itself does not move around the stator. It is only the seat of the resultant flux which keeps on shifting synchronously around the stator. Mathematically prove let phi 1 is equal to phi max sine omega t and phi 2 is equal to phi max sine omega t minus 90. Phi r square is equal to phi 1 square plus phi 2 square, and phi r square is equal to phi max sine omega t square plus phi m sine omega t minus 90 degree square. So that is equal to phi m square sine square omega t plus cos omega square t, that is equal to 1, because sine square omega t plus cos square omega t is equal to 1. Now what is the remaining, that is phi m square. So take just under root both hand side, it will be phi r is equal to phi max. It shows that the flux is of constant value and does not change with time. खाना दवार बन को three phase supply, three phase supply. Now that was a two phase supply. Now we will see for the two phase supply. It will now be shown that when three phase windings displaced in space by 120 degree are fed by three phase currents dis- displaced in time by 120 degree, they produce a resultant magnetic flux which rotates in space as if actual magnetic poles were being rotated mechanically. So now look at over here. This is a three-phase supply, and three set of windings are connected with a three-phase supply, and each of displaced by a 120-degree. Now, the principle of a three-phase two-pole stator having three identical windings placed 120-degree space degree apart is shown in the figure. The flux assumed sinusoidal due to the three-phase winding in shown figure or here. Now these are the phase 1, phase 2 and phase 3, which is 120 degree apart from each other, and the resultant flux is phi max. So now we will look around these three phase supply, and we will look around the resultant flux and their displacement clockwise. So now the assumed positive direction of the fluxes are shown in the figure. Let the maximum value of flux due to any one of three phases be phi max. The resultant flux phi r at any instant is given by the vector sum of the individual fluxes, that is phi 1, phi 2 and phi 3 due to three phases. So the resultant flux phi r at any instant is given by the vector sum of the individual fluxes phi 1, phi 2 and phi 3 due to three phases. We will consider values of phi r, which is the resultant flux at 4 instants 1 by 6th time period apart, corresponding to a point marked 1, 2 and 3 in the figure over here. That is 1, 2, 3 and 4. Okay. When theta is 0, that is corresponding to point 0, here phi 1 is 0, phi 2 is minus under root 3 divided by 2 pi max, and phi 3 is equal to under root 3 divided by 2 phi max. The vector for phi 2 is the vector for phi 2 in a figure is drawn in a direction opposite to the direction assumed positive, so the resultant phi is equal to 2 into under root 2 divided by 2 phi max cos of 60 divided by 2. So that is equal to 3 by 2 phi max. Now look at our here. So phi phi r, which is the resultant flux, is equal to 1.5 phi max on a point of theta is equal to 0 degree. Now look at our here, it will be shifted further clockwise with the same magnitude of phi r. So now at theta is equal to 60 degree, that is corresponding to a point 1. Here phi 1 is equal to under root 3 divided by 2 phi max. Phi 2 is equal to, now it is minus under root 3 divided by 2 phi max, and phi 3 is equal to 0 here. Is drawn in a direction opposite to the direction assumed positive. Now the resultant flux R is equal to 2 into under root 3 divided by 2 phi max cos of 30 divided by 2. So now it is equal to 3 by 2 phi max. It is found that the resultant flux is again 3 by 2 phi max, but has rotated clockwise through an angle of 60 degree. Now it is shifted 60 degree clockwise with the same magnitude of phi r, that is 1.5 phi max. Now, when theta is equal to 120 degree corresponding to point 2, here phi 1 is equal to under root 3 divided by 2 phi max, phi 2 is equal to 0, and phi 3 is equal to minus under root 3 divided by 2 phi max. It can be again proved that resultant flux phi r is equal to 3 by 2 phi m, that is the phi max. So the resultant is again of same value but has further rotated clockwise to an angle of 60 degree. So that is magnitude of phi r is equal to 1.5 pi max again, and it is shifted further 60 degree from initial point. It is from the previous point, it is shifted 60 degree clockwise. Now when theta is equal to 180 corresponding to point 3, here phi 1 is equal to 0, phi 2 is equal to under root 3 divided by 2 phi max, and pi 3 is equal to minus under root 3 by 2 pi max. It can be again proved that phi r is equal to 3 by 2 phi max and has rotated clockwise through an additional angle of 60 degree or through an angle of 180 degree from the start. Now this is the resultant vector for the phi r is equal to 1.5 phi max, and theta is equal to at theta is equal to 180 degree. Hence we conclude that is that the resultant flux is of constant value, that is 3 by 2 phi max, that is 1.5 times the maximum value of the flux due to any phase. And the resultant flux rotates around the stator at synchronous speed given by ns is equal to 120 f by p. So now this is the diagram for the rotating magnetic field, which is shown with the help of a phase shift of 60 degree from the previous one, and it is rotated clockwise on each interval. It is shifted 60 degree, so that is a diagram. So as seen, position of the resultant flux phasor have been shown at an interval of 60 degree only. The resultant flux produces a field rotating in the clockwise direction. So mathematically prove taking the direction of flux due to phase 1 as reference direction, we have phi 1 is equal to phi max cos of theta 0 plus j sine theta into sine omega t, and phi 2 is equal to phi max cos of 240 degree plus j sine 240 degree into sine of omega t minus 120, and phi 3 is equal to phi max cos of 120 degree plus j sine 120 degree into sine of omega t minus 240. Expanding and adding the above equation, we get phi r is equal to 3 by 2 phi max sine of omega t plus j cos of omega t is equal to 3 by 2 sine 3 by 2 phi of max at angle of 90 degree minus omega t. The resultant flux is of constant magnitude and does not change with time t. So that was a lecture on our rotating magnetic field, which is an initial understanding for the AC machine. or induction machine, or maybe a synchronous machine. In a synchronous machine, rotating magnetic field is very important role, is very important, and the main role of rotating magnetic field is to, that is the synchronous speed of the synchronous machine. And all of the induction machine, that may be a single phase or maybe a three phase, are working on this principle. When you learn the rotating magnetic field or production of rotating magnetic field, it will be very easy for you people that to learn the concept of single phase, three phase, and synchronous machine working principle. So I hope that this lecture will add another understanding of the electrical machine, and we will have some other machines which are based on rotating magnetic field. So دا بیا لږ سټډي کوي او لږ ځان پې پوه کوي چې یار دا روټیټنګ میگنیټک فیلड څه ته وایي ځکه چې دا بیا زمونږ فردر پکارېږي فردر हमारे काम आएगा सिंगल फेज थ्री फेज एंड सिंक्रोनस मशीन में ये रोटेटिंग मैग्नेटिक फील्ड का काफ़ी जो है ना वो इम्पोर्टेंट रोल है फर्दर हम जो है ना इसको प्रूव नहीं करेंगे सिर्फ हम कहेंगे कि भाई ये यहाँ से जो है ना हमें रोटेटिंग मैग्नेटिक फील्ड आता है सो hope you all guys are enjoyed this lecture. I'm just taking your attendance over here. बया भाई इंशाल्लाह गप लगाओ ठीक था